apologize, it quit recording again. There's another split, which is annoying. So maybe it's believable that this Zn goes to P, because the even terms all go to P. The odd index terms go to P, by assumption. So it's got no other choice. In particular, that means that this sequence Zn is Cauchy. But that means f of Zn is Cauchy, and so it's also convergent. Let's let L be its limit. So apparently, all I need to show, well, what will I try to do? So I'll try to show the limit of Wn is also equal to L, and so is the limit of xn, where xn is the sequence we studied before, which was f of Wn is L. The limit f of xn is also L, but we already knew that the limit of f of xn was y, so y is equal to L, which will give me what I want. So let's do that. So then it follows that f of xn, well, by the formula, xn over 2 is always Zn when n is even. So f of xn is f of z sub 2n. That means f of xn is a subsequence of f of Zn. So P, which is the limit, y, which is the limit of f of x sub n, this is a subsequence. Well, no, it's equal on the nose. F of x sub n is the same as f of z sub 2n. But this is now a subsequence of f of Zn. So the subsequence has to have the same limit of the big sequence, is equal to L. So y is equal to L. So f of Zn converges to L. I needed to show that f of Wn converges to L. On the other hand, f of Wn, let's see, Wn plus 1 over 2 is the same as Zn. So let's see what I need to plug in. So n plus 1 over 2 equals, I don't know, k. Double it, n equal to 2k, subtract 1. So f of Wn is the same thing as f of 2n minus 1. So right, there's an odd number. Take 2n minus 1, add 1 to it, you get 2n plus 2. Divide by 2, you get, nope, 2n minus 1 plus 1 is just 2n. Divide by 2 is n. So z sub 2n minus 1 is w sub n. So that means f of w sub n is a subsequence of f of Zn, because of course it is. So that means the limit of f of w sub n is the same as the limit of f of z sub 2n minus 1. This is a subsequence of f of Zn, so this limit has to be the same as that. But I already know that that's L, which is also equal to y by this line. So what do we see here? We've proven that for every sequence w sub n of elements of u minus singleton p, because we considered any sequence wn, such that w sub n converges to p, we've proven that f of w sub n converges to y. By the sequential reformulation of what it means, well, of the limit, we see then that the limit, as x approaches p, of f of x is equal to y. In particular, the limit, as x approaches p, of f of x exists. And that completes the proof of the theorem. Cool. So I'll see you in class on Wednesday. In the meantime, check out this video at your leisure. I'll upload another one, at least that's my intent, over the course of this weekend. I will see you around.